Hello students, welcome to Modern Group of Education Kolkata. So today we are starting electric dipole. This is the very important topic of class 12 for road and NEET joint, JEE main advanced, etc. Okay, so for that you have the knowledge of electric field intensity. So please go and watch the electric field intensity lecture from our channel Modern Group of Education, and then come here. Then it will be easy for you to understand this lecture. Okay, so electric dipole means to equal and opposite charges, opposite charges separated by a small distance, very small distance. Okay, very small distance. Two equal and opposite charges are separated by a very small distance, but the small distance, how much small distance, you don't know. So there is a plus q and minus q charge. Obviously they are equal in charge, should be equal in charge, equal in magnitude, but opposite in sign, with some distance 2d between them. Actually the dipoles are just like this, q and minus q, and there is a distance of l plus l, 2l. Okay, took l plus l, 2l, or d plus d, 2d. Sometimes in questions, in some question there is there is a distance between two dipole is like total distance is l. So total distance, distance will be l by 2 and l by 2. Okay, some example of dipoles are HCl and HF. It is written in here. Okay, now comes the important topic, which is dipole moment. Dipole moment, p vector, it is a vector quantity. So what is the dipole moment? The value of dipole moment is equal to q into separation between the charges. Separation between the charges. So if the distance separation between them is 2d, then q into 2d, q into 2l, etc. If the separation between them is l, then it is q into l. So actually the formula is q into 2l, but sometime I told you that sometime in the questions it is they tricked the question that the distance will be in l length. So that there, for that questions the dipole moment will be q into 2l. That's why I have written that the q into separation between the charges. Clear? Now this is the scalar formula of dipole, but dipole is a vector quantity, so it has some direction. What is the direction? Direction of dipole moment is negative charge to positive charge. Negative charge to positive charge. In chemistry, you learn that the dipole moment, direction of dipole moment is positive to negative charge. But in physics, the dipole direction of dipole moment is negative to positive charge. Okay, so this is the dipole moment. Clear? Now coming the derivations of electric field intensity due to dipole. For two cases, one is axial point and another is equatorial point. So axial point. Find electric field intensity at the axial point of a electric dipole. Say this is a dipole separated by 2l distance. This is the center of the dipole. Center of the dipole is much important every time. So this is 2l. Okay, so at the center and the axis point, you have to find the electric field intensity at the axis point. This is the axis point. So let's find the electric field intensity at that point. This is the axial point. Okay, now assume that the distance between the point from the center is x. Distance from center of the dipole to that point is x. Now at that point you have to find the electric field intensities. For that, the plus q charge will repel the charge because there is a test charge. Okay, you have to apply the test charge here. The plus q charge will repel the test charge like this, and the minus q charge will attract the charge like this. Say it is E1 and it is E2. Okay, E1 will be in smaller value, so E1, the length of the arrow of E1 is smaller, and E2 will be of greater value, so length of the arrow of E2 will be higher, will be greater. This E2 will be the attraction field of minus q charge, and this is the electric field. E1 is the electric field of plus q charge. Okay, now then E net will be E2 minus E1. Obviously E2 is greater than E1, so E2 minus E1. Now coming to E2 means kq by, this length is x minus L. Okay, so kq by x minus L square, and E1 is kq by x plus L square. Clear? So kq gets common. Now 1 by x minus L square minus of 1 by x plus L square. If we LCM the value, then it will be x plus L whole square into x minus L whole square. In the numerator you will find x plus L whole square minus x minus L whole square. Okay, so in the numerator, this is the formula of 4ab, a plus b whole square minus a minus b whole square. This is the formula 4ab, 4 into x into L, and the numerator it is a plus b whole square into a minus b whole square. That means a square minus b square whole square. That means x square minus L square whole square. Okay, so this is the formula of net electric field on the axial point. But here some assumption comes. The assumption is x is much greater than L. X is much greater than L because dipoles are having very short length. I already told you that two equal and opposite charges separated by very small distance, just like a thickness of hair. Okay, the distance will be just like a thickness of a hair. So x will be much greater than L. Now we have to put the assumption. So if x is much greater than L, then x square minus L square will nearly equal to x square. Okay, so kq into 4xl by x square, 1x get cancelled out, so it will be 4kq into L by x. Q into 2L covers P, and another 2 remains here, the 2kp by, sorry, it is x to the power x square minus L square, where it will be x square, so it will be x to the power 4, and 1 gets cancelled out 4, so it will be x cube, so 2kp by x cube. So the electric field, the value of electric field is 2kp by x cube, and you have to remember this value because for the equatorial portion the value will be just like same with some negligible changes. So you have to remember these formulas, 2kp by x cube. So the electric field along any axial point is 2kp by x cube. Okay, clear? 2kp by x cube. You have to memorize these things in like music, like harmony. Okay, you have to remember, you have to again and again tell this thing in by your mouth, so that it will get some harmony. 2kp by x cube. Okay, now coming to the equatorial point. electric field on the equatorial point or perpendicular bisector. This point is also called as perpendicular bisector. Equatorial point, perpendicular bisector. There are two, three names of this topic or this point. Perpendicular bisector, broad away point, broad on point, etc. Okay, so let's start. This is a positive charge again, and this is a negative charge. These charges are separated by 2L distance. This is the center of the dipole. Sorry, I have to draw in with some space here. Hmm. This is the minus Q. Excuse me. This is the minus Q plus. This is the plus Q, and this is the minus Q. These charges are separated by 2L distance. This is the center of the dipole. Center of the dipole is much important because all the distance are taken from the center of the dipole. So this is L and this is L. The perpendicular bisector point will be in this direction. So this is the perpendicular bisector point. Okay. Now this length is x from the center of the dipole. That's why I am telling that the center of the dipole is much important. This is the center of the dipole, and you have to draw some lines to prove the value, to find the value. This line and this line, but in dotted form, obviously in dotted form, because these lines are not actually valid lines. These are not firm lines. Firm lines will be, these are also not firm lines. There is no actually firm lines. Okay, so at this point there is a test charge, so plus Q will repel this charge. 1 minute. The plus Q will repel this charge like this, and the minus Q will attract this charge like this. Okay, so the resultant will be in this direction. Resultant will be in this direction. Say this is E1 and say this is E2. This distance is L and it is x, so it is root over of, this distance will be root over of x square plus L square, and this distance also root over of x square plus L square. Sorry, root over of x square plus L square. So these distances are same. That means E1 and E2 are same. So if E1 and E2 are same, then the resultant will be root 2e in this direction. E1 and E2 are same just like E. So resultant will be root over E square plus E square. That means root 2e. Okay, in this direction. So now find the E. The value of E will be k into q by x square. X means root over x square plus L square whole square. Root over x square plus L square whole square, that means kq by x square plus L square. So the net resultant will be the net resultant will be root 2e, but there is some perpendicular, there is some horizontal or vertical component of this thing. Say this is theta angle, so this is also theta. That means this is e cos theta, e1 cos theta, and e2 this is theta, this is theta, and this is also theta quadrant angle. So this is actually root 2e. Before writing root 2e, you have to write this thing like e1 cos theta plus e2 cos theta, and there here e1 sin theta, and here e2 sin theta. e1 sin theta, e2 sin theta gets cancelled out because e1 and e2 is equal to e. So e sin theta, e sin theta gets cancelled out, but 2e cos theta here added will be added. So 2e cos theta. Okay. Now you have already found that the e, that means 2e, that means kq by x square plus l square, and cos theta will be, from here cos theta will be base by hypotenuse, that means base means L and hypotenuse means root over x square plus L square, L by root over x square plus L square. So now the formula comes 2kql by x square plus L square whole to the power 3 by 2. That is the formula of E net before applying the assumption. Now applying assumption, here is also x is much greater than L. This x is much greater than L. So after applying assumption, that x is much greater than L, that means x square plus L square will remain equal to x square. So the E net will be 2kql by, only there this will be x square to the power 3 by 2, that means x cube, and q into 12 means p, that means kp by x cube. So the formula of axial point, electric field at axial point will be kp by s cube. The axial the electric equatorial point will be kp by s cube, and in the axial formula, in the axial formula, the formula of E net will be 2k, E net was 2kp by x cube, and now here it is kp by x cube. That means we can write that E axial is equal to 2 into E equatorial. This is the most important point, important result, and most of the times this question directly comes that E axial equal to 2 into E equatorial. Very, very important. Okay, but these are the values 2kp by s cube, kp by s cube are the only the scalar values. Now you have to find the directions. Okay, in axial, the direction of p, the direction of p is minus q to plus q, and then E net is also minus q to plus q. Okay, the direction of p is in this direction, p, and the E net will be also in this direction because E2 minus E1 has this direction. So here the angle between E net and P is 0 degree. So we can write the formula of E net is 2kp by s cube along the direction of P. Okay, so we can vectorially write this as E vector is equal to 2kp vector by x cube. This is actually 100% right equation because the direction is same. But in equatorial point, the p direction of p is in this direction, changing the color. So the direction of p is in this direction, negative to positive. This is the direction of p vector, but the direction of E net is in this direction. E net is in this direction. So the angle between E and P, so the angle between E and P is 180 degree. That means if we have to apply the vector formula, then this formula vectorially will have another an extra minus sign, kp vector by x cube. If you want to write the scalar form, then this is the right form, because in scalar form we do not apply the direction, but in vector form you have to apply the vector direction, and you have to write that E net will be minus kb by s cube. That means 180 degree angle. Clear? Okay. Now, so electric field axial and equatorial are there. I have write the axial equal to into equatorial, but electric field in at any point, electric field at any point. Okay. Actually, this is the general formula. In this formula, if we find the formula, then you just by applying the angles, you will get the axial and equatorial values. Okay. Now electric field at any point. Again, this is the plus charge and minus charge separated by 12 distance. This is the center of the dipole. Say this point is in this direction. Okay. There is a point is in this direction. This is not the axial point or not the equatorial point. Now you have to join this with the center point. These are all the dotted line. These are not the farm lines. Okay. So this distance is x. Now you have to join again those points like this, like this. Okay. So this is the point. Now we don't know the direction of electric field in this direction. The plus q will repel this force here, the minus q will repel this force in this direction, but we do not know the angles. So let's put an angle that is r comma theta. That is this is x comma theta. Okay, this angle is a theta angle. Clear? The r comma theta, that means polar coordinate. Polar coordinate. If we apply the polar coordinate, then it will find we will find any point from space. So r comma theta, that means x comma theta is applying here. Now this proof have some tricks, that the direction of p is in this direction. Changing the color, the direction of p is in this direction. Okay, the direction of p is in this direction. So this is p. If we change the direction of p with some theta angle, that means this is p. If we draw that this is p, if p has some components, like this is p cos theta and this is p sin theta. Actually, just you have to opt the plus minus values, then it will be easier for you. But because this is the p is going in this direction, and there is the components is in this direction, the direction is opposite in direction. Okay, so you have to just change the plus minus values here. Just change, here is minus and this is plus, this is minus, then it will be easier for you, sorry, easier for you to understand. Minus q plus q. Okay, now now see that this is the direction of p. Okay, minus to power plus, sorry, this is the direction of p. Now if we change the p direction of, if we take some components of p in these directions, we can write that this direction has the component of p. Actually, this is p cos theta because the theta angle is there, and this is p sin theta. Now for the p cos theta, this is the axial point, and for p sin theta, this is the equatorial point. For p sin theta, for p sin theta, for p cos theta, this is the axial point, and for p sin theta, this is the equatorial point. We have already learned about the cos theta, about the axial and equatorial formulas. So we are applying this technique. For p cos theta, this is the axial point. So the E axial for this point will be, sorry, changing the color. E axial will be 2kp 2kp. Actually the formula is 2kp by x cube, but here p cos theta is there, so the 2kp cos theta by x cube. Okay, 2kp cos theta, 2kp cos theta by x cube. And for p sin theta, this is equatorial point, so E equatorial will be 2kp sin theta by x cube. Now you have to find the actual E from E net. Okay, so the E axial will be the direction. I am drawing the direction of E axial. E axial will be in this direction. For p cos theta, this is E axial, and equatorial in equatorial direction, the p cos p, this is the p sin theta, the equatorial direction will be in this direction. Here is the direction of p, so here will be the direction of equatorial. Okay, now so the direction of E net will be is in this direction. Clear? So E net will be root over of E axial square plus E equatorial square. So it will be 4k square p square cos square theta by x to the power 6 plus 4k square p square sin square theta by x to the power 6. So it will be 4k square p square sin square theta, 4k square p square cos square theta. So if we take the common, then 4k square p square by x to the power 6 will get common, 4k square p square x to the power 6, and there will be cos square theta plus sin square theta. 4k square p square by x to the power 6 is common. Okay, here is 2kp by x cube, sorry, here is kp by x cube, not 2kp by x cube. So this is 2kp, not 2kp by x cube, this is kp by x cube. That means here also here only k square p square by sin square theta. So this is wrong. So here if we take the common and from get out from the root, then kp by x cube into root over of 4 cos square theta plus cos sin square theta. 1 sin square theta plus 1 cos square theta, that means 1. So it will be 1 plus 3 cos square theta. Take 1 cos square theta from 4 cos square theta and plus 1 sin square theta. Cos square theta plus sin square theta is 1. So 1 plus 3 cos square theta. This is the answer. E net kp by x cube into root over 1 plus 3 cos square theta. So this is the ultimate general form for the equatorial and axial at any point formula. If we apply the theta for axial, the theta is 0 degree, and for equatorial the theta is 180 degree. So for axial, the formula will be E net will be kp by x cube into 1 plus 3 cos 0. Cos 0 means 1, 1 plus 3 means 4, root 4 means 2 kp by x cube. So we have checked the value. For equatorial, the theta is 180 degree. So the value of E net will be kp by x cube into 1 plus 3 cos square theta. Cos 180 means minus 1, that means plus 1. So cos 180 is minus 1, so it will be plus 1. So 1 plus 3, 4, again 2, no, sorry, 90 degree. For equatorial, that is 90 degree. This is not the angle between E and P. This is the angle between the point and the dipole. That is 90 degree. So cos 90 is 0. So this will be 1 kp by x cube. This angle is not the angle between E and P. This is the angle between perpendicular. This is the angle perpendicular bisector. So theta is 90 degree. Okay. So we have checked all the values. So this is the actual general formula, but you have to remember separately both the formulas, because these formulas are very important and it will be very handy for you. Okay, so this is the dipole and the direction of dipole, all about dipole. So in electrostatic 1 you have this only, but for electrostatic 2 you have another thing of dipole, just like potential and torque of dipole. So we'll learn about them in later, but this is the uh, 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 all the things for the electrostatic 1 about dipole. So this is the end of the video. If you like the video, please watch, and please subscribe our channel and share the video to your friends, and more the share, more is the reach of us. And if you want to join our institute, then please comment below and call the numbers or mail us. Okay, so tata, bye bye, we'll meet in the next class. Tata.